Welcome back. Today we're going to continue our study on accelerated motion. We will utilize the guess method by identifying the variables that are given, the unknown variable, then finding the appropriate equation, manipulating that equation to solve for unknown, substituting in our variables, and then finally solving for our unknown. Now for our first question. A sprinter starts from rest and accelerates at a rate of 4.7 meters per second squared. How long does it take that sprinter to reach a velocity of 16 meters per second? First, we must identify what the question gives us. Notice that the question states that the sprinter starts from rest. This indicates that our beginning velocity is 0 meters per second. The question also states that the sprinter accelerates at a rate, therefore our acceleration is 4.7 meters per second squared. Lastly, the question gives us that the final velocity is 16 meters per second. We know that this is our final velocity because it says that the sprinter reaches a velocity of. The question is then asking for how long does it take. This is going to be our unknown variable. Our unknown variable for this question is the time. Next, we need to identify which formula to use. Which equation do we need to use? In our notes, we previously discussed that we identify which equation to use by the absent variable. Notice that this question does not indicate displacement at any point. It does not give us or ask for displacement. Therefore, we should know to use this equation. Another indicator that this is the appropriate equation is that the question is giving you the initial velocity, the final velocity, the acceleration, and then of course asking you for the time. So we have each one of those variables. We're going to record our formula, but notice our equation is not written in terms of our time. To get time on the opposite side, we'll have to multiply both sides by time. Cancel this out. We're going to divide by the acceleration on this side. Therefore, our equation is final velocity minus initial velocity divided by the acceleration. Next is to substitute in our numbers. Time is equal to our final velocity of 16 minus our initial velocity of 0 divided by our acceleration of 4.7. Now we just need to plug this into our calculator. So we have 16 divided by 4.7. For this answer, we now have 3.4 seconds. Okay, on to our next question. A Lamborghini accelerates from rest and travels a total of 35.1 meters to a velocity of 27 meters per second. How long does it take? First, we need to identify what the question gives us. Notice that the question states that the Lamborghini starts from rest. This will be our initial velocity. It states that the Lamborghini travels a distance of 35.1 meters. This will be our x displacement, 35.1 meters. And it says to a velocity of. This is telling us our final velocity, 27 meters per second. Question then says, how long does this take? This question is asking us for time. Next is to identify which equation are we to use. Notice that this question gives us initial velocity, displacement, final velocity, and time. The missing variable is acceleration. Looking at your equations at the top, this equation includes acceleration. You cannot use this equation. This equation includes acceleration, and so does this one. That's one way to eliminate your equations. Notice that this formula here does not indicate your acceleration, so that will be our formula. So we've got x is equal to our initial velocity plus our final velocity divided by 2 multiplied by our change in time. Next is to rearrange the equation to solve for that time variable. The first thing that we will do is to multiply both sides of the equation by 2. I always like to look at the equation, and because this has a fraction or 1 in the denominator, I want to get this out of that denominator. So I'm going to multiply this whole side by 2. Whatever I do to this side, I now have to do to this side. Notice that that 2 cancels out, and that leaves us with our initial velocity plus our final velocity multiplied by our change in time is equal to 2x. The next thing we need to do is to get this parentheses portion over to the other side. Let's clean this up so it's easier to see. Time. So to get this to the other side, we're going to have to divide by that entire portion in the parentheses. Okay, notice this cancels out, and now our formula that we are to solve. Okay, next we need to substitute in our variables. So the question gave us our x to be 35.1. So I have t is equal to 2 times 35.1 divided by 0 plus our 27. Next, we need to plug this into our calculator to solve. So I have 2 times 35.1 and I'm going to divide that by 27. This gives us our time to be 2.6. Time is equal to 2.6 seconds. Okay, on to our next question. A unique type of basketball is played on planet Zarth. During the game, the player flies above the basketball and drops the ball in from a height of 10 meters. If the ball takes 5 seconds to fall, you need to find the acceleration due to gravity on planet Zarth. First, notice that this question is not on Earth, therefore our acceleration due to gravity will not be 9.8. We need to identify what the question is giving us. Notice that the question states that it drops from a height of 10 meters. This is going to be our y displacement. This is a vertical, so we're going to call it y instead of x. So this will be our 10 meters. Question also gives us a time of being 5 seconds, and anything that's being dropped in that y direction. So here's your basketball. As it's being dropped, that initial velocity has to be 0. Just that moment right before it's dropped is the initial velocity has to be at 0. After that moment, it's going to accelerate due to gravity, and in this case, it'll accelerate due to the gravity on planet Zarth. So our initial velocity is 0, our height is 10, and our time is 5. So those will be our given variables. The question is asking us for, or our unknown variable, is the acceleration due to gravity on planet Zarth. Looking at our variables, the question is giving us our displacement, our time, initial velocity, and asking us for acceleration. To identify our variables here, we can't utilize this first formula because the question does not give us final velocity. Again, because final velocity is not included in our variables, we cannot use the second equation. And we can't use the third equation because the final velocity is not given. Therefore, we will use this equation. I'm going to write the equation in terms of y equals our initial velocity times time plus 1/2 a t squared. Need to rearrange this equation to solve for our acceleration. We know that our initial velocity is 0. 0 times any number is our time, so this part will go away. That leaves us with y is equal to 1/2 a t squared. We're trying to get our a by itself. I'm first going to multiply both sides by 2 so I can get rid of this fraction. Then I'm going to divide both sides by t squared so I can get a by itself. Our equation is a is equal to 2y divided by t squared. Now we need to substitute in our numbers. So a is equal to 2 times 10 divided by 5 squared. Let's do our math. We have 2 times 10 divided by 5 squared, which is 25. Our answer is 0.8. Acceleration due to gravity on planet Earth is 0.8 meters per second squared. Okay, for our last question, we have a volcano that erupts and throws ash into the air with a speed of 625 meters per second. How high could this volcanic plume have risen? Notice that the equation is giving us the initial velocity. The question states that it throws the ash at a speed of 625 meters per second. So the initial velocity is 625 meters per second. Let's just visualize this. If this is our volcano and it's throwing ash up, the question's really asking for how high that plume has risen when it throws the ash out at that 625 meters per second. Meaning that if that ash rises all the way to the highest point, the final velocity is going to be 0 meters per second. This is on Earth, so we know that the acceleration is going to be, our acceleration will be -10. Notice that the object is rising, therefore it's slowing down, therefore its acceleration is going to be -10 meters per second squared. The question's asking for our change in our y displacement, therefore it's looking for our y. Looking at the equations, we're going to find the equation that does not include our time variable. The question does not give us or ask for anything in reference to the time, therefore we cannot use this equation, and we cannot use this equation. Another way to identify it is that our initial velocity is given, our final velocity is known, our acceleration, since we're on Earth, is also known. This question is asking for that displacement, so this will be our equation. So final velocity squared is equal to our initial velocity squared plus 2 times our acceleration multiplied by that change in that y displacement. We need to rearrange this equation to solve for our y. Notice that this vi squared, our initial velocity squared, is being added to ay. First thing we want to do is subtract this part over. So we have our final velocity squared minus our initial velocity squared is equal to times our acceleration and our y. Again, we're looking for this y variable, so we're going to divide both sides by 2a to give us our equation. Y is equal to final velocity squared minus initial velocity squared divided by 2a. Next is for us to substitute in our variables. The question gives us that our final velocity is 0 squared minus our initial velocity is 625 squared divided by our acceleration, 2 times our acceleration, which was -10. Now we'll plug this into our calculator. One big mistake that students make is not to square their velocities. So the first part is 625 squared, and that will be in our numerator. So I'll have a -3,90625 divided by 2 times -10, that's -20. That gives us our answer of 1953125. And that's in meters. All right. So next up, you're going to answer a couple questions on this ed puzzle. Please feel free to go back and review any of these equations, and of course, ask questions if you have them. Thank you.